Dear students, now we will see second application of transistor as a switch. In our first application we saw transistor as an amplifier, and when we saw that application we saw that transistor was operated in active region. If you operate transistor in active region, that is if the emitter base junction is forward bias and base collector junction is reverse bias, then only you can use it in amplifier application. Okay. Similarly here, now you are going to use transistor as a switch. Now in this we are going to use the other two modes of operation. One is the saturation mode and one is the cutoff mode. Okay. So here the first one what we are showing is transistor in cutoff mode. Now this is a transistor which is connected in a common emitter type configuration. So emitter, you can see it is common to the input also, to the output also. Now here the base and the collector and emitter, three terminals are shown. Emitter is connected to ground, base is given as the input along with a R resistor, you can name it as R. Then you can have a VCC supply which is given to the collector, okay, through a R resistance RC. Now here the base current will flow IB and here the collector current will flow IC. Clear? Now if this voltage is 0, if the input voltage what you are giving to the base is 0, now this transistor is NPN transistor, NPN. So the P type of semiconductor is getting an input of 0. That means it is less than the cut-in voltage. It is less than the cut-in voltage. That means base emitter junction will not forward bias, it will reverse bias. Now base emitter junction reverse bias, as usual collector junction is also reverse bias. So both are reverse bias. That means you are in cutoff region. You are in cutoff region. The transistor is not allowing any current to flow. Even the small leakage current will not flow because it is in an open mode. It is become open because you have reverse bias the base emitter junction. Because the base emitter junction is reverse bias, this is acting as an open switch, and you can show this. This is your open switch. This is your open switch. You can see the same emitter connection to the ground, VCC supply, but here transistor, there is no joining between collector and emitter and the current will not flow. So it is called as an open switch. And now here students, in the second case, when we see the same type of diagram, transistor is connected in common emitter configuration only and same type of VCC supply is given to the collector. Now here one difference we are going to make as compared to the first case is we are going to give input as plus 5 volt. You are going to give input as plus 5 volt. Okay. That means the applied voltage will be more than the cut-in voltage. Applied voltage will be more than the cut-in voltage. In that case, this junction between emitter and base will be forward biased. Junction between emitter and base will be forward biased. Similarly, the junction between base and collector also will be forward biased, and the transistor goes into saturation. The collector current increases and it goes into saturation. Saturation means the collector and emitter are not connected. They are not open. So if you convert that diagram in an equivalent circuit, you can see this switch is closed. This switch is closed between collector and emitter. Okay. So if you give the input as plus 5 volt, it is going to act as a closed switch. If you give the input as 0 volt, it is going to act as an open switch. So in this way, transistor can make a break or make circuit. It can open or close. So hence we can tell that transistor is acting as a switch. So this is the second application of transistor, which is very important. The first application was it was used as an amplifier. The second application is it is used as a switch.